All right, it is 6 o'clock. Thank you so much for coming here, attending online class. I hope everyone has been enjoying the reading week. Any questions before we start? Can somebody confirm that you can hear me and you can see my screen? I can't hear you. I also want to hear from you. Can somebody speak up? Thank you, Logan. So you are muted. So I'm going to unmute you. One moment, please. But if I unmute all, so I'm going to unmute all participants. Please mute yourself. You can speak up only when you have questions, okay? Okay, can somebody confirm that you can hear me and you can see my screen?
I can hear you and see you.
Yep, I can hear you and see and the screen you're sharing.
Appreciate. That's great. Again, if you do not have questions, you do not have to speak, please keep your microphone off to minimize the background noise. Okay. All right. I'm going to double check the technology. So you can hear me, you can see my screen. I will also try to make sure this meeting is being recorded. I will post the lecture recording after we finish the lecture, okay? Okay, if you have any questions, I am monitoring the chat area. You can type in the question in chat area or directly speak up. Okay, so as usual, some logistics. Reminder about important due dates. So today is week 7, February 27th. Our next coming due date, March the 2nd, online assignment 3, and then March 9th, written assignment 3. Okay. If you have difficulty following up with the course content, you want to maintain academic good standing, the last day to withdraw from this course is March the 10th without academic penalty. Okay. Our term test 2, it is actually, the date is decided. The format, probably the test 2 will be in person, probably, okay? So stay tuned for the format for test 2. The date is Friday, March 17th. The format probably is in person. Okay. All right, so those are the logistics. Are there any questions, anything? Remember, you can visit the Mathematics Learning Center. Virtually every day, somebody is there to help you, okay? We have Neil Marshall, is helping all fourth-year students, include MATH1p97. We have Professor Huda, okay, and my office hours. This week, my office hours is changed to Tuesday from 10 to 11:40. through Microsoft Teams. Okay. Next week forward, my office hour would be in person Monday from 4 o'clock to 5:30. Okay. That being said, are there any questions? When we'll receive our midterm marks for term test 1? You can check your term test 1 mark on WebAssign. It is available now. Check your mark on WebAssign. Okay. What time is it? Maybe you mean what time it is. When we'll get our written assignment 1 mark, what time is the term test 2? Stay tuned. Okay. Probably Friday, you know, maybe the same time as test 1, probably. Okay. Any other questions? All right. Okay, so last class we finished chapter 4. Today is our week 7. We'll do 4 sections of chapter 5. Exponential functions, logarithm functions, the derivative for exponential functions and logarithm functions. Okay, so that is today's content. I try to manage my screen so that I can also see your questions. If the second midterm test in person, probably there is a 95% chance test 2 will be in person. Okay. I will make announcement once the information is available. Okay, we're all good. All right. So exponential functions. Suppose you deposit 10,000 in account earning interest at 10% per year compounded continuously. This is in real life. We most often use compound interest. Okay. Graphically speaking, this is how it looks like after certain years. Okay. And this graph represents the exponential growth, exponential functions, if the interest rate is compounded continuously. Okay. And if you are using the simple interest, maybe the money grow like the straight line. This is simple interest. And this one is compound interest. So what is simple interest? It is just interest on the principal. The compound interest is on principal and interest is on interest. Okay. So now let's formally define exponential function. The function f(x) equal to b raised to power x. B is a number greater than 0. B is not equal to 1. And we call this function exponential function. And we call b is the base, x is the exponent. The domain of the function is all real numbers from negative infinity to positive infinity. Okay. For example, f(x) equal to 2 raised to power 2x, that is exponential function. Okay. Another example would be f(x) equal to maybe 1/3 raised to power x. It is also exponential function. Okay. Keep in mind b must be greater than 0. So if you say fx equal to negative 2 raised to power x, that is not exponential function because we restrict b greater than 0. Okay, so this is not exponential function. And if you say fx equal to 1 raised to power x, this is not exponential function because b not equal to 1. Okay, so not exponential functions. So if you have fx equal to 2 raised to power x, so if we are talking about this one here. So what is f3? f3 means plug in x equal to 3, and you get 2 raised to power 3, it is 8. Okay. X could be any number from negative infinity to positive infinity. Okay. So x could equal to, for example, negative 1 over 2. If x equal to negative 1 over 2, and then fx becomes negative 1 over 2 equal to 2 raised to power negative 1 over 2. Okay, so equal to 1 over 2 raised to power positive 1 over 2. So equal to 1 over square root of 2. Okay. Another example would be f negative 2 over 3. So just plug in x with negative 2 over 3. Okay, when you have negative as exponents, you use 1 over. Remember, x negative n equal to 1 over x positive n. Okay. And this one, when x equal to 0, so all we are talking about fx equal to 2x, 2 raised to power x. Just plug in x with the 0, you get equal to 1. Okay. So when x equal to negative 1, plug in x equal to negative 1, then use this rule, x negative n equal to 1 over x raised to power n. The last one, you can take this one. X equal to 3 over 2. What is fx? So I pause for a moment to see if you have any questions.
Sorry, excuse me. I actually have a question.
Oh, sure. Go ahead.
It's just for with 2 over 3. So when we're equaling 2, and it's 3 divided by 2, are you essentially multiplying 2 with the exponent 3 divided by 2, or?
Okay, thank you for your question. I guess your question is about this one, right?
Yes, it is.
Okay, thank you for asking question. So first, when x equal to 3 over 2, you just plug in x with 3 over 2, you get this one. No question about this one, right?
Mm-hmm.
And then, what is x raised to power 3 over 2? This is the question, okay? So I'm going to write something on side. So the question becomes, what is 2 raised to power 3 over 2? This is the question. Okay, so by definition, remember we will have x raised to power m over n. What is x raised to power m over n? It is x m square root of n. So we apply this rule. So this becomes 2 raised to power 3 square root. This is 2. Is that okay?
Okay.
Okay, now.
Yes, it is, yes.
Yeah, now 2 raised to power 3, it is the same as 2 raised to power 2 times 2 raised to power 1. Square root, usually these two, we omit these two. Okay? And then continue. 2 raised to power 2 square times square of 2. And this square root, this 2 cancelled out, you have 2 times square root of 2. Here, final result.
Okay.
Thank you for your question, Dana. Any other questions? Okay. Make sure when you go home, you go over those, what is F3, what is F0, to see if you can come up with the correct answer. Okay. Okay, some properties of the exponents. When you have bx times by, it is bx plus y. For example, if you have 2 raised to power x times 2 raised to power b, what this? It is equal to 2x plus b. Okay. The second one, if you have bx over by equal to bx raised to power b, x minus 1. So if you have 3 raised to power 4 over 3 raised to power 5, so this is a 2, okay? This is example of 1, equal to, keep the same base, it is 4 minus 5, see x minus y, so 3 negative 1 equal to 1 over 3. Okay. And the third property said, if you have, for example, 3 raised to power 2, and then raised to power 4, it is the same as 3 raised to power 2 times 4, equal to 3 raised to power 8. This is number 3. I just want to give you concrete example to illustrate the exponent properties. Okay. So number 4, if you have 4 times 6, just for example, raised to power 7, it is the same as 4 raised to power 7 times 6 raised to power 7. This is example of property 4. And the last one, property 5. So if you have 5 over 6 raised to power 3, just for example, equal to 5 raised to power 3 over 6 raised to power 3. Okay, so those are the laws of exponents. Any questions?
Yes, sorry, I have a question, ma'am.
Sure.
Also, when you use multiplication, you can multiply the coefficients or the actual numbers that are raised to the powers. But when you're adding,
can you identify number 1, 2, 3, 4, 5? Which one you are talking about?
Number 1. If
oh, thank you.
If it's b raised to the power x multiplied by something like c raised to the power y, does it become bc raised to the power xy? I mean x plus y.
I'm sorry, I didn't quite get your question.
Okay, let me
Can
try
you
to
rephrase your question?
If it's b raised to the power x multiplied by c raised to the power y.
Oh, brilliant question. Now I understand your question. Thank you, Anasu. The question was, if it is d raised to power x times c raised to power y, it will not equal to d times c raised to power x plus y. No. Okay. The first property, you must have the same base. if you have a different base, one is C, the other is D, you cannot use property 1. Thank you for your question. Hope that answered your question.
Yes, it did. Thank you.
Okay. So you are thinking, okay. Any other questions? All right. Now let's look at the example, okay. Let's do this. So for this one, we have base 16. Base 16, if you have the same base, you just add exponents. So keep the same base, just do the components, add components. In this case, it is 7/4 plus -1/2. So it is 7/4 minus 1/2 here. Okay, so 7/4 minus 1/2 is 5/4. And what is 16 raised to power 5/4? So you rewrite, do you agree 16 is the same as 2 raised to power 4? That is 16. And then copy down the exponents. 5/4. Okay, and then apply law 3. Law 3. Okay, when you are here, you apply law 3. It is 2 raised to power 4 times 5/4. So 4 and 4 cancelled out. You have 2 raised to power 5. And it is 32. Any questions?
I have a question.
Yes, please.
Sorry to interrupt. So do you, with these examples that are given, do you always have to do this process with each part that's equal to that specific answer? So since we got 2 to the power 5, do we have to show that kind of work to showcase why it exists in that third step?
So if I understand your question, right, do you need to show all your steps? You can, it is required to show all the steps, just on safe side.
Okay.
Okay, thank you for your question. Okay. Any other questions? Okay, so this one we use law 1, we also use law 3. Okay, just fresh. So this is law 1, law 3. Okay, question B. Question B, we are going to use law 4, law 2 first. Number 2, if you have B raised to power x over B raised to power y equal to B x minus y. Okay. So B is 8. Okay. X is 5/3. Y is -1/3. So Bx over By equal to Bx minus y. This is step 1. Okay. And then step 2. Minus negative equal to plus positive. This is step 2. So 5/3 plus 1/3. Okay. Continue. Okay. So 6/3. 6/3 is 2. And you got 64. Questions? So again, please do this by yourself even now to see if you can come up with the 64. Okay, you have to put your hand on this question. Okay, next question. 64 raised to power 4/3, then raised to power -1/2. This one, we need to use the property, okay? So b raised to power x, then raised to power y equal to b raised to power x times y. So b is 64, x is 4/3, y is -1/2. So these two fractions comes together, okay? So equal to 64 negative. So 4 times 1 is 4. 3 times 2 is 6. So -4/6 is the same as -2/3. And then you apply x raised to power -n equal to 1 raised to power n. So 1/64 raised to power 2/3. Okay. And then you use this law again. So 2/3 is the same as 1/3 raised to power 2. Why we need to do that? Because we know 64 is 4 raised to power 3 equal to 64. Then raised to power 1/3, and then raised to power 2. The purpose we are doing change 64 to 4 raised to power 3 is that we want to cancel this 3 with this 3, canceled out. So you just have 4 raised to power 2. And the final result, 1/16. I pause for a moment to see if you have any questions. Any questions? Okay. It is all about hands-on. You need to put your hands on this question to make sure you get 1/16. Okay, without looking at the solution here. Okay, this question. You have 16 times 81 raised to power -1/4. Okay, so first, we apply the rule. If you have, for example, m times n raised to power b, just for example, it is equal to m raised to power b times n raised to power b. Okay, use this property. So we have 16 raised to power -1/4 times 81 raised to power -1/4. And then we use x raised to power -n equal to 1/x raised to power n. So change the negative to 1/. Change the negative to 1/. Use this one. And then we know 16 is 2 raised to power 4. 2 raised to power 4 is 16. And then raised to power 1/4. 81 is 3 raised to power 4. And then raised to power 1/4. And then we use the law, b raised to power x, then raised to power y equal to b raised to power x times y. So 4 times 1/4, it is raised 1. 4 times 1/4 is 1. So the final result would be 1/6. Questions? Okay, can I move on to next one? Okay, this one. So first, we apply, if you have m over n raised to power x, it is the same as m raised to power x over n raised to power x. Apply this, you get this. It is actually just skipped one, so the first step you should get is equal to, so the first step you should get equal to 3 raised to power 1 over 2, then raised to power 4 over 2 raised to power 1 over 3, then raised to power 4. This is step 1. And step 2, you go here. In step 2, you use a raised to power x, then raised to power y equal to a raised to power x times y. So you are here in step 2. So 3 raised to power 1 over 2 times 4. So it is 4 over 2. Then 1 over 3 times 4. Okay, and this is your final result. And how do you get this one? Maybe I will do more steps. So 3 raised to power on the top, you have 3 raised to power 2. No, 3 raised to power you have 4 over 2. 4 over 2, it is 2. So 3 raised to power 2 on the top. On the bottom, you just have 2 raised to power 4 over 3. Okay, any questions on the exponents examples? Okay, now let's look at the one we talked about. They call actually law. There were 5 laws. Now it is the properties. Okay. So first of all, if you look at the graph of y equal to b raised to power x, what it looks like. It is actually looks like this. So this is y equal to b raised to power x. So as you can see, x could be any number from negative infinity to positive infinity. So x could be any number from negative to positive. And the range is the y value. Y always greater than 0. See, all the y are greater than 0. And this graph passing through this point is 0, 1. When x equal to 0, y equal to 1. Okay. All right. And if it is increasing, if b greater than 1, so like this. It is decreasing if this one is b greater than 1. If b smaller than 1, it is decreasing. So the graph would be like this. If b smaller than 1, the graph will be like this. Y equal to b over raised to power x. Any questions? The properties of exponential functions. Okay, so far, the exponential function we're talking about, we call this B. B actually stands for BASE, base. If this base is a special number E, so what is E? This number is E, 2.71828, okay? And this number is E. So how do we get this number E? It is actually use the limit. E is the limit of m goes to infinity. 1 plus 1 over m raised to power m. That number is E. But we do not prove. We just use this result. Okay. So when you have E as the base, generally speaking, we have y equal to b raised to power x. When b equal to this E, natural number, E is natural number, and we get y equal to E raised to power x. Remember this E is greater than 1. Why? Because E equal to 2.71828, 18. Okay. So how do we know what is this graph looks like? So this is the graph because E greater than 1. When you have a base greater than 1, the graph always looks like this. Okay. You can get this graph using the algebra. I'm going to show you. So you just type in y equal to exp x. Press enter, and you got this graph. Okay. Just type in y equal to exp. It will automatically translate to E. Okay. All right. And when you manually do it, you can get some x value. Some x are negative, some x are positive. When you have x, you calculate for y, then you make a plot. Okay, and you'll get this graph. Any questions? How to sketch the graph of function y equal to E raised to power x?
Yes, I have a question.
Yes.
It might be a bit dumb, but like when y is equals to 0, how do you then solve for x?
Sorry, when y equal to what?
0. In this equation, y is e to the power x. How do you solve for x?
Y equal to E raised to power 0?
No. 0. Y is equals to 0. Like when y is 0, how do you solve for e to the power x?
Thank you. When y equal to 0, how do you solve for x?
Yes.
Could someone please mute yourself if you are not have questions? There are some background noise. Thank you. Okay, this is your question. Y equal to 0. How do you solve for x? There is no x such that y equal to 0. In short answer, you cannot solve this question. Which question? Y equal to 0. Because y will never be 0. Y will never be 0.
Oh, okay.
Why? If you look at this graph, you see
Yes.
y is always on x. You see this graph?
Yes.
Always positive. Why? y will never be 0. X could be 0. See, when x equal to 0, y equal to 1. When x equal to 0, y equal to 1. Okay? Thank you for your question. Any other questions? All right. Shall we move on? Okay, so we finished session 1, exponent function. Y equal to b raised to power x, that is 5.1. Now move on 5.2, logarithms. Logarithms. Okay. Okay, so what is the logarithm? If you have b raised to power y equal to x, the number y is called logarithm of x to the base b and denoted by log b, base b, x. Now, under b greater than 0, b not equal to 1. Okay, now let's just play around the notation here. We just have 3 letters, b, y, x. Now I will change the letter. You tell me, okay? What would be the logarithm? So if I say a raised to power b equal to c. So I ask you, what is b equal to? Can someone give us the answer? Just play around with the notation.
Log c to the power a.
Log c. Log a to power c. Yes, this is correct. Okay, great. So now, if I have x raised to power y equal to z, and what is y? Y equal to log base x z. Logarithm base x z. So just play around with the notation. All right. So what is the connection between logarithm and exponent functions? What is the relationship? So if you have y equal to log base bx, you must have x equal to b raised to power y. Let's practice the notation. And this is if and only if. So on the other hand, if x equal to b raised to power y, then y must equal to logarithm base b x. Okay, because this is if and only if. And now I will change letters, okay? So I will say if a equal to b raised to power c, then you tell me what is c? Anyone? What is c? Anyone want to try?
It's log a base b.
Log a base b. Thank you. Correct. Okay. And now if x equal to log x base a, then x equal to what? Oh no, I have to use different letter, sorry. This is y. Anyone want to try?
would be y equals log.
Look at here. So,
Sorry, my bad. It would be a to the x power, right?
perfect. Thank you. Great try. Yeah, great work. So just play with the, different letters, okay? Okay, so any questions? All right. And you need to remember base greater than 0, base not equal to 1. Okay. And x is greater than 1. Greater than 0. Okay. Do exercise, do some examples. I will use another approach. So this gives you the direct answer, but I will use another approach. So I will do log 100 base 10. So I will use log 100 is the same as 10 raised to power 2. And then this is base 10. So then there is a properties. There is a properties. I will write down the properties. I will hope you will write down. So log, if you have log a base b, then raised to power n equal to n times log a base b. Okay? And then you also have if the base is the same as, if those two numbers are the same, it is equal to 1. So for example, log x base x equal to 1, log a base a equal to 1, log 20 base 20 equal to 1. As long as you have the same number, it is 1. Okay? Okay, now go back to this question. So now use this property. I move 2 in front of the log. I got 2 times log 10 base 10. And then I use this property. I got 2 times 1 equal to 2. Because log 10 base 10 equal to 1. Okay. Questions? Okay. Next, log 125 base 5. So this one, I will write down 125 is the same as 5 raised to power 3. So keep the same base. I just rewrite 125 to 5 raised to power 3. And then move this 3 in front of the log. So you get log 5 base 5. When you have log number and base number the same, it is equal to 1. 3 times 1 equal to 3. Oops. Okay, questions on number B? Okay, question C. Question C. So first, I will write down 1 over 27 is the same as 3 negative 3. 3 raised to power negative 3 equal to 1 over 27. And then move negative 3 in front of the log. You have log 3 base 3. So equal to 3, negative 3. Questions? So question D is easy. If you have the number is the same as the base equal to 1. Okay, any questions?
Or actually,
Yes.
start the class and
Yes, please.
For part C, if we go step by step,
started late 20.
the first step would be to make log 1 over 27 be log 27 to the power negative 3.
I'm sorry, can you identify A, B, C, D? Which one you are talking about?
C.
Thank you. Question C.
Yes. Do you mind going step by step one more time?
Thank you so much. I will go detail step for question C. I will write it on the side, okay?
Okay.
So question C. Log 1 over 27 base 3. Just double check. Yeah. This is question C. Okay. So first, I will keep the base 3. I just rewrite 23 to 3 raised to power 3. Okay.
Why can't
And
we
then
write?
I use
Sorry.
property 1 over xn equal to x negative n. Use this property. So it is 3 negative 3. Use this property. After that, I move negative 3 in front of log. This is because there is a property log. If you have a, b, then raised to power x, you can move x in front of log. This is property. And then lastly, this is equal to 3, because if you have log b base b equal to 1, this is a property. Okay. Hope that answered your question. Any other questions? So again, it needs practice. Okay. So where do you start practice? Start by redo the examples in class and then do more examples from the textbooks. Now I just say a question. Sorry, I missed that question. So s equal to 1 would be your relative minimum. Relative minimum. We don't have relative minimum here. So sorry. Can you elaborate your question, Spencer? Today we don't have relative minimum question. Oh, that was from a long ago. Thank you. Okay. Okay. Thank you, Spencer, for clarifying. Okay. Okay, guys. Shall we take a break? 10 minutes break. Make sure you take some water, get some fresh air. Come back at 7:04. Okay, 7:04. We resume. All right, welcome back. Hope you have had a nice break. Are there any questions? All right. So let's continue. Please type in your questions in chat area or directly speak up. Okay, so far we talked about the logarithm functions. Y equal to log x base b. So how about if this b equal to 10 or if b equal to the natural number e? So this is our topic right now. If base b equal to 10, we call it is common logarithm. If base b equal to e, it is natural logarithm. They are just terminologies, okay? And if base is 10, we usually write log x. We omit 10. If base is e, we write down the log is ln instead of log. So those are the notation. Okay. So the laws of logarithm. If you have log m times n base b, it is equal to log m base b plus log n base b. For example, if you have log 2, and then if you have 3 times 4, this equal to log 3 base 2 plus log 4 base 2. That is the law 1. Okay. Next, I'll give you an example for log b. Okay. So if you have log 5/7 base 9, just for example. So it is equal to keep the same base 9 So log 5 base 9 minus log 7 base 9. That is log 2. A concrete example. Then number 3. So if you have log 2 raised to power 5, base is 4, just for example. So you can move 5 in front of log. It is just log 2 base 4. Number 4. If you have log 1 base, for example, 2, it is 0. If you have log 1 base 3, it is 0. If you have log 1 base 5, it is 0. Generally speaking, log 1 is 0, regardless of what is the base. Actually, the base must be greater than 0, not equal to 1. Last one, log b base b equal to 1. For example, log 2 base 2 is 1. Log 5 base 5 is 1. Log 10 base 10 is 1. Any questions? Now let's look at example. So this one, log 2 times 3, it is just log 2 plus log 3, directly application of number 1. Direct application, okay? It didn't specify the base, means it is 10. So this one is the same as log 10. 2 times 3 equal to log 10. Log 2 base 10, okay, plus log 3 base 10, the same thing. We omit 10. Now, if you have just ln, means the base is e. The second one. Okay. So apply number 2. Apply number 2 for the second one. You get ln 5 minus log 3. Number 3, first square root, you write down raised to power 1 over 2. And then move 1 over 2 in front of log, because we have log m raised to power n base b equal to move n in front of log. Use this property. Question D, any log 1 equal to 0. Log 45 base 45 is 1. Any questions? Okay, now we are going to go over logarithmic functions and their graphs. So we know what is the log function, fx equal to log x base b. b greater than 0, not equal to 1. So what is this function looks like? I will skip this one actually. So the logarithm function is this blue line. This is log b, log x base b. What is the relationship between logarithm function and the exponential function? They are mirrored by y equal to x. This straight line is y equal to x. If this is y equal to log x base b, and this must be y equal to b raised to power x. Okay. They mirror each other based on y equal to x. Okay. So this is the properties of logarithm function. Okay, we already know logarithm function. It is so what is the logarithm function? This is x. this is y. So this is y equal to log x base b. So this is 0. So domain, as you can see, only take positive number as x. X could be any positive number, but y could be a very negative, big negative number to positive number. That is y. And this graph passes through 0, 1, 0. When x equal to 1, y equal to 0. And the logarithm function is continuous. Okay. And when b greater than 1, it is increasing. B smaller than 1, it is decreasing. So this graph actually b greater than 1. And what is the logarithm when b smaller than 1? When b smaller than 1, it becomes this. So this is y equal to log x base b when b smaller than 1. So it is decreasing. I pause for a moment to see if you have any questions. We are good. All right, make sure it is recorded. I'm sharing my screen. Okay, example. How do you sketch the graph y equal to log x? One way, sorry for my dog. Maybe quiet. So the exponential function y equal to ex is this one. And we know logarithm function is just mirror about y equal to x. Okay. So as a result, this is the logarithm function, y equal to log x. So how do we use the algebra to graph y equal to log x? So you just type in y equal to ln x. So this is the graph. Okay. Any questions? Okay, so this is the algebra. Mary, quiet. Hey, sorry. Mary, what's going on? Be quiet. Sorry for the disruption. My dog is barking. Okay, so properties related to exponential function and logarithm function. Those are two important properties. So if e means exponential raised to power, and the power part is the logarithm function. And the result, it is just x. You can consider this e cancelled out with this ln, so the result is x. Similarly, you should take logarithm first, then exponential function, log and e cancelled out, you get x. Okay. Okay, let's take a look at example. Solve the equation. Solve for x. The first step, we move this 2 to the other side. Move this 2. Both sides we divided by 2. On the left-hand side, we have ex plus raised to power x plus 2. Right-hand side, 5 over 2. Okay. And then remember, if you have e raised to power x equal to y, so what is x? X equal to ln y. Okay. So use this property. We have x plus 2 equal to ln 5 over 2. Okay. And then x equal to ln 5 over 2 minus 2. So here, x equal to ln 5 over 2 minus 2. So roughly is negative 1.08. And how do you, actually you can get this using Excel. Or plug in regular calculator. Okay, any questions? Okay, let's conclude logarithm function. Next, we'll move to compound interest. Okay. Some notations. I represent the interest earned. P represent the principal. Small r represent the interest rate. T is number of years. So the interest equal to principal times interest times years, PRT. Accumulated amount, we use A, represent accumulated amount. It is just principal plus interest. And interest is PRT. So take out the common factor P. You have P, bracket 1 plus RT. That is the accumulated amount. Okay. But the compound interest is the interest not only on principal, but also on interest. So now let's do our example. Suppose you have $1,000. This is your principal. You deposited in a bank for a term of 3 years. Earn interest at a rate of 8% per year. So what is the accumulated amount at the end of first year? So you use the formula A equal to P times 1 plus RT. P is the principal, 1,000 here, P. R is 8%. This is R, 8%. 1 year, T equal to 1. Okay, and you got $1,080. And now, to find the accumulated amount at the end of the second year, we use the same formula. Accumulated amount equal to P times 1 plus RT. But this P is the result of at the end of first year accumulated amount. Okay. So what happened in the second year? So this part is at the end of first year times 1 plus RT. The result would be at the end of the second year. Any questions? So this P is actually A1. So if you plug P equal to A1, it is A1 times 1 plus RT. And what is A1? A1 is P times 1 plus RT, then 1 plus RT. You get here. So this one is actually P, 1 plus RT times 1 plus RT. The result is at the end of second year. Any questions? And similarly, you can calculate the accumulated value at the end of third year. Okay. So at the end of third year is this amount. So at the end of third year, it is actually used at the end of second year times 1 plus RT. R is 0.08, T is 1. This is at the end of third year. The final result should be here. This is at the end of third year. Any questions?
Question.
Yes.
So can you just write it as A equals P bracket 1 plus R to the power of T?
Not to the power of T. It is just R times T. R times T, not to the power of T.
Okay, but I was thinking like if you had 1 plus R like to the power of 2 or like 3, you would just get like the same answer. I don't know.
Okay, there are different ways to do it. You do have power 2 here. We do see power 2 here.
Okay, I didn't see that.
Depending on, yeah, if you want to directly use the previous result, you do not need the power. For example, at the end of year 1, we got, this is at the end of year 1. At the end of year 2, we use A2. We use the result of year 1 at the end of year 1 times 1 plus RT. T is 1. This is at the end of year 2. Okay. So at the end of year 2, it is no, Mary, stop. Sorry, Mary. Hey. Mary, what do you want? No, no. Sorry for my dog. So what I am explaining is that if you directly use the result from the previous year, you do not need the power. This is what I'm explaining now. At the end of year 1, you got 1080. At the end of year 2, directly use the end of year 1 result, you get this number. At the end of year 3, you use the previous year, means end of year 2, plus 1 plus RT. R is, sorry, 0.08, 0.08. And this is year 3. And year 3, you get so this way, you do not need to use power, okay, exponent. But if you do it algebraically, you need this power. The reason is this part is at the end of year 1 times 1 plus RT becomes this whole part here is at the end of year 2. That's why you have this power. Okay. The reason we want to use power, we want to generate general expression. How about at the end of n year, 5 year, 8 year, 20 year? That is the reason. Okay. So as a matter of fact, we have, for example, at the end of year 3, you get this. So based on this pattern, at the end of year 2, you should have your principal 1.08 raised to power 2. At the end of year 4, you should have 1.08 raised to power 4. At the end of year 5, the cumulative money is 1,000 times 1.08 raised to power 5. Okay? Any questions? Because of the compound effect. I pause for a moment to see if you have any questions.
So like, for example, let's say it was like year 6, then it would be like, sorry, can I see the other examples again?
Yeah.
Yeah, so if let's say it was year 6, it would be 1,000 times 1.08 to the power of 6?
Correct.
Okay.
Year 7, the accumulated money 1,000 times 1.08 raised to power 7.
Okay.
Okay? Yeah. This is the reason you want to use the power. If you do not do multiple years, you just do 1 year, 2, year 3, you can directly use the previous year's result, like I did here. See, I didn't use any power, any exponent here. Directly use the previous year's result times 1 plus RT. So this I can call method 1, and then you have method 2 here. 2 different methods will generate the same result. Okay, questions? So this is the general formula. At the end of 4th year, you got principal times 1 plus R. 2nd year, principal times 1 plus R raised to power 2. 3rd year, P times 1 plus R raised to power 3. So T year, you got this. Any questions? Okay, now a new concept. Sometimes the interest is compounded 2 times a year. Sometimes the interest is compounded 3 times a year or 6 times a year. In this case, we introduce the interest rate per conversion period, small I. Small I use annual interest rate over periods per year. So for example, if annual rate is 8%, and if interest is compounded quarterly, when you have compounded quarterly, M equal to 4. So what is the interest per interest quarterly? This I represent interest per quarter. So it should be 8% divided by 4. So interest per quarter is just 2%. Okay. So another example would be, if the nominal rate is 8% and interest is compounded semi-annually. So I change this question to compounded semi-annually. Interest is compounded semi-annually. When you have compounded semi-annually, M equal to 2, because 1 year you need to do 2 conversions. In that case, if interest is compounded semi-annually, I equal to 8% divided by 2 equal to 4%. Any questions? Now I will give you a question. You try to answer this question. Interest rate is 8% per year. Interest is compounded monthly. If interest is compounded monthly.
Cool.
Please mute yourself if you do not have questions. Okay. Thank you. If interest is compounded monthly, what is I? Somebody try to answer this question.
Would it be 12?
Wow, excellent. So 8% divided by 12. Perfect. You get the idea. Terrific. Any questions? Okay, now if interest compounded every day, compounded daily. Interest is compounded daily. What is I? If annual interest is 8%, interest is compounded daily. What is I? Anyone? The question is, the annual interest is 8%, and interest is compounded every day. What is periodic interest? What is little I?
Would it be 365?
Perfect, thank you. So 8% divided by 365. So hope you understand this I, small I. Okay. All right. So we actually already learned this. At the end of 1 year, first year, at the end of second year, accumulated value, at the end of third year, accumulated value. At the end of n year, you get raised to power n. So let's do at the end of fifth year. So A5 equal to P, 1 plus I raised to power 5 at the end of fifth year. So at the end of 20th year, you got A20 equal to P, 1 plus I raised to power 20. That's it. All right. Now, try to understand this part, our partial movement. So in T years, how many periods in T years? The answer is n periods in T years. What is n? It is m times T. I will give you an example. Okay, if interest is compounded quarterly, interest is compounded quarterly, what is M? Anyone? I give you the hint. By definition, M represents number of conversion periods per year. Now I give you interest compounded quarterly. I ask you what is M?
4.
Excellent. 4. 1 year you need to do 4 conversions. So if interest is compounded monthly, what is M?
12.
Interest compounded monthly, M is 12, fantastic. Interest is compounded semi-annually. What is M?
6.
Think it again.
2.
Excellent, 2, because 1 year you make 2 conversions. Okay, so you understand M. And now, if I give you 5-year period, over 5-year period, if interest is compounded quarterly, how many conversion periods in 5 years? That is N. What is N represent? I repeat my question. I have a 5-year period. Interest is compounded quarterly. My question is, what is N? n represents m times t. 5 years means t equal to 5. So n equal to m times t. When you compound it quarterly, m equal to 4. 5 years means t equal to 5. So n equal to 20. I pause for a moment. Hope you understand what is n. I give you this example, explain what is n. If you have 5-year period, interest is compounded quarterly, n equal to m times t. That is the definition here. Okay, that is the definition. Okay, any questions? Now there is a formula for accumulated amount at the end of t years. This t could be 1 year. This t could be 2 years, 3 years. Generally speaking, it is t year. So A equal to Mary tired. Sorry. What are you talking? Sorry for the distraction. Okay, the formula is what is accumulated amount at the end of t year. This is the formula. Use the principal times 1 plus r over m. R over m. What is r over m? Anyone remember? R over m is that small I. And then raised to power mt. What is mt? Mt is n. So this formula can also be written as A equal to P. 1 plus I raised to power n. N equal to mt. I equal to R over m. So n equal to mt. I equal to R over m. R is the nominal rate per year. Those are the explanation, all the notations. I pause for a moment to see if you have questions, because this formula is important. Okay, let's take a look at the example here. Find the accumulated amount after 3 years if 1,000 invested 8% per year, compounded annually, semi-annually, quarterly, monthly, daily. The question asks you, what is the accumulated amount after 3 years? That is the question. Okay, so how do we solve? I will solve A, B, C. You do question, I will solve A, B, C. You do question D and E. Okay. Okay, annual. So first of all, identify the formula. So this is the formula. Okay. In this formula, we need to calculate I. We need to calculate n. Okay, so I equal to, when you have annually, compounded annually, okay, first identify m and t. If you have compounded annually, what is m? Anyone?
One.
M equal to 1, why? Because by definition, M represents 1 year. How many conversions? 1, because it is annually. Okay. And then, so we need M. After 3 years, so T equal to 3. T equal to 3. Formula, we need T. Okay. And then what is R? R is annual rate 8%. Okay. So in order to calculate accumulated value, we need this formula. A equal to P times 1 plus I raised to power N. So we need also calculate N. What is N? N is M times T. M is 1, T is 3, N is 3. Okay. And now we are ready. So just plug in this formula here. I will rewrite the formula. A equal to P, 1 plus I raised to N. P, 1000 is P. 1 plus I. What is I? I is R over M. R over M. R is 8%. M is 1. So I is 8%. N is 3. So this is the final answer. Okay. You can use regular calculator. I usually use Excel to do the calculation. So what I need to do, I want to calculate 1000 times 1 plus 8% raised to power 3. Okay. And the result is so I finished question A, part A. Any questions? Okay, now let's do B. For B, what is M? When you have interest compounded semi-annually, what is M?
2.
Excellent. Remember, M represents 1 year. How many conversions? Okay, 2 conversions, 1 year. And then what is N? N equal to M times M is 2, T is 3. See, this is T 3 year, T is 3. So N equal to 6. And then we need to calculate I. I is R over M. So 8% over 2, 4%. Okay. So we have everything we know. Okay. A equal to P. 1 plus I raised to power N. P is 1000. I is 4%. Raised to power N. N is 6. Okay. So now I'm going to just change Excel. 1000 times 1 plus instead of 8%. It is 4%. 4% raised to power 6. So this is B. Any questions? Okay, let's do C. Interest compounded quarterly. 1 year, how many conversion? 4, m equal to 4. N equal to m times t. So 4 times 3, 12. I equal to R over M. So it is 8% over 4. It is 2%. 2%. Okay. And now A equal to P. 1 plus I raised to power N. P is 1000. I is 2%. Raised to power 12. So what is this number? 2% raised to power 12. So raised to power 12. It is 2%. Any questions? Sorry, my dog likes people. She likes people very much. She is barking at another dog. There are 2 dogs here. Okay, 2 dogs here. She is barking at another one. Another question, why not replace 2 with 0.02? Why not replace 2 with 0? You can replace 2% with 0.02. Yes, you can replace 2% with 0.02. Okay. Okay. Shall we take a break? After break, we continue. Remember, you need to do part D and part E. Okay. So come back at 8 o'clock. Break back at 8 o'clock. Okay, welcome back. Any questions? All right, let's continue. So before break, we calculated accumulated amount for compound interest after 3 years in different situations. Okay, so now we move on. A new concept, effective rate of interest. So what is the effective rate of interest? It is just the simple interest rate would produce the same accumulated amount in 1 year as the nominal rate compounded m times a year. It is also called a true rate. So we use notation R subscript EFF represent effective rate. Okay, so now the cumulated amount after 1 year at effect rate. So if you have rate after 1 year, accumulated amount equal to P times 1 plus R, because it is T, should be times T, T equal to 1. This is on one hand. On another hand, the accumulated amount after 1 year at interest rate R per year compounded m times is this formula. Remember, this is the same as P1 plus I raised to power n, I equal to R over m, n equal to m times T. Because T equal to 1, so m times 1 equal to m. So we want these two expressions equal. Let them to be equal. Why let them to be equal? Because we want because they produce the same accumulated amount. The same accumulated amount. Two situations produce the same accumulated amount. Situation 1, you use effect rate. Situation 2, compounded m times, they should produce the same amount. Okay, and then from here, we solve for the effective rate. Both sides we have P, and P cancelled out. Okay. And now you can solve for effective rate equal to 1 plus. This is the formula for effective rate. And the effective rate formula is this. Now let's do example. Found the effective rate of interest corresponding to nominal rate of 8% per year. A, compounded annually. B, compounded semi-annually. C, compounded quarterly. D, compounded monthly. E, compounded daily. So I will do A, B, C. You do D and E. Okay. All right. So let's just straight use this formula. Okay. So situation A, when you have compounded annually means
one year.
yeah, 1 year. Okay. So m equal to 1. So first of all, let's plug in the formula. Maybe just do it here. When you have annually, m equal to 1. Okay. And R is 8%. This number is R. R is 8%. Okay. And then you just plug in this formula. So equal to 1 plus 8% raised to power 1 minus 1. It is 8%. It's just 8%. This is A when you have situation annually, compounded annually. Okay. So now, situation B, when you compounded semi-annually. Situation B, semi-annually. Semi-annually means m equal to 2. Okay. So effect rate equal to 1 plus 8% over 2 raised to power 2 minus 1. Okay. So I need Excel to facilitate the calculation. Actually, yeah, here. Oops. So I want to do 1 plus bracket equal bracket 1 plus 8% divided by 2 raised to power 2 minus 1. And it is 0.0816, so 8.16%. Situation B, if it is compounded semi-annually, the effect rate 8.16%. Situation C, if you have compounded quarterly, compounded quarterly means m equal to 4. So effective rate equal to 1 plus 8% divided by 4 raised to power 4 minus 1. Okay. So equal to 1 plus 8% divided by 4 raised to power 4 minus 1 is the equal sign. So 8.24%. Questions about example 2? You do D and E, same principle. When you do D, M equal to 12. When you do E, M equal to 365. Okay, and plug in effective formula. All right, so we did that. Effective rate of, so you can look over. Now we talk about the present value. Remember A equal to P times 1 plus I raised to power N. or A equal to 1 plus, because R equal to R over M, N equal to MT. So those are the same formula. And now when you solve for P, what is P? Both sides you divided by 1 plus R over M raised to power MT. Left-hand side divided by 1 plus R over M raised to power MT. Okay? And you got cancelled out. So you got right-hand side P, left-hand side A over 1 plus R over M MT. Then you switch left-hand side and right-hand side, you got negative MT. So that is the present value formula. What is A? A is accumulated value. A is also called future value. P is the present value. Any questions? Okay, let's take a look at the example. How much money should be deposited in the bank, paying interest at a rate of 6%, compounded monthly, so that at the end of 3 years, the accumulated amount will be 20,000. So this 20,000 is accumulated amount is A. And interest rate R is 6%. Compounded monthly means M equal to 12. 3 years means T equal to 3. Okay, and plug in the present number formula P. Remember P equal to A 1 plus R over M raised to power negative M times T. Plug in this formula. A equal to 20,000, R 6% or 0.06, M 12, T 3, and you get this result. Okay, so if you use Excel to facilitate the calculation, use Excel to facilitate calculation equal to 20,000 times bracket 1 plus 0.06 over 12 raised to power negative 12 times 3. This is the result, the same as here. And this is Excel formula. Any questions? Okay, continuous compounding interest. So far, we talked about compounding annually, compounded semi-annually, compounded quarterly, maybe compounded monthly, compounded daily. You could have compounded hourly, compounded every minute, compounded every second. Keep on going. That is the concept of continuous compounding. Did you get it? Continuous compounding. Compounded every second, okay, continuous compounding. This is the concept. Okay, so if continued compound, okay, let's look at here. When you have compounded annually, M equal to 1, compounded semi-annually, M equal to 2, compounded quarterly, M equal to 4, compounded monthly, M equal to 12, compounded daily, 365, compounded hourly, you have 365 times 24. I don't know what is this number, but I can find out. compounded hourly, you have 365 times 24. Okay. And imagine, keep on going. So M, did you see M goes to bigger and bigger and bigger? So virtually M goes to infinity. When you compound it continuously, M becomes infinity. Okay? So when you have M goes to infinity, take limit. Let M goes to infinity. What is this limit? That is the question. Okay? And to solve for this limit, we need to use a property. We need to use an axiom. Okay, it is like 1 + 1 = 2. That is true everywhere. Okay, so what we need to use, when you have we need to use this 1 + 1/x raised to power x. When you take limit, x is very big. This result is e. Natural, okay, remember this e roughly equal to this number 2.71828, etc. Okay, so use this result to calculate what is the limit. What is the limit for this expression? This is our objective. This is what we are going to do right now. Okay. All right. So what do? We already know this. We are asked to find this limit. So what we do a little bit algebra here. So first, m times t, we use raised to power t. See, we raise to power t here. Raised to power t because of this law. Okay, and then we use substitution. And we use substitution. We use u equal to m/r. So if u equal to m/r, 1/u equal to r/m. So this r/m is 1/u. Okay. And then what is m? If u equal to m/r, m equal to u times r. U times r is m. And then we put this r out, combine the r with t together. The purpose, we want to produce this format because we know this guy equal to e. Okay. So the final result equal to e raised to power rt. Okay. Questions? This need a little bit algebra to use the existing equation here. This one here. Use this one. Another way to look at it is this. I will use another way. So our objective is to find this limit. To find this limit, you do a little bit algebra, you do this. So this is M over R then times RT. It still hold true. Because R and R, this R and R cancelled out, you get MT here, right? The reason I put it this way is to produce this result. What this result said is that this part times this part equal to 1. So I have R over M and I have M over R. Okay, so I can safely say this is E raised to power RT. Directly get the result without using the substitution U. I directly get the result because of this property. Any questions? All right. So this is when you have continuous compounding. When you have continuous compounding, what is this? This is accumulated value equal to P times E raised to power RT. Okay. Accumulated value A equal to P times E raised to power RT. Now look at example. Find the accumulated value after 3 years if 1,000 is invested at 8% per year. Question A, compounded daily. Question B, compounded continuously. So if you have compounded daily, M equal to 365, R is 8%, T is 3 years, T equal to 3. So use formula A equal to P 1 plus R over M raised to power M times T. Plug in the number P 1,000, R 0.08, M 365, T equal to 3, and you get this amount. When interest is compounded daily. Okay. And now, question B, when interest is compounded continuously, we use this formula. A equal to P times E raised to power RT. So question B, use A equal to P E raised to power RT. P is 1,000, E raised to power R, R is 8%, T is 3 years, 8% times 3. So I need this number. Okay, so calculate in Excel. So equal 1,000 times E. Excel, you need your EXP represent E. EXP raised to power 8% times 3. So this is the number. So this is compounded continuously, okay? If you compare the result with compounded daily, they are similar. They are similar. compounded continuously, compounded daily. Any questions?
Do we always, when it comes to using the example that we have in B, will we have to, will we always have to use that formula for if the question is always asking for something continuously?
If the question asks you for continuously, you must use A equal to P times E raised to power RT. Yes.
Okay.
Although the result similar to compounded daily, but you have to use the correct formula. Okay. Thank you for the question. Any other questions? Okay, we did this. So we finished session 3 of chapter 5, compound interest. Compound interest, present value, future value, and effective rate. Last session in chapter, not last session, last session in today's lecture, derivative of exponential function. Derivative of exponential function. Let's directly dive into the rule of exponential function. So the derivative of EX, it is just EX. Okay. And how do we know? We use 4 steps. Remember, we use 4 steps rule. Let's do it. So remember, what is the derivative? Derivative, it is just the limit. Maybe I will do this. So first, what is fx? Fx is e raised to power x. If this is fx, what is fx plus h? So plug in x with x plus h. That is fx plus h. Okay. And then calculate fx plus h minus fx over h. So equal to ex plus h. Remember, fx is ex raised to power x over h. Okay. And then ex plus h equal to ex times eh minus ex over h. On numerator, factor out ex, you have eh minus 1. Okay. And then each time you do the limit, so you just add the limit. H goes to 0. Limit, h goes to 0. Limit, h goes to 0. Okay. So now we need to know because it is h goes to 0, so we take ex away. So h goes to 0. So we need to figure out what is eh. E raised to power h minus 1 over h. And it is turned out this one equal to 1. We can use algebra to prove this one. Why this is equal to 1? Okay, we can draw a graph. Okay. So when you draw the graph, you have this curve here. So when h goes to 0, Let me see. X minus 1 over x. So this curve, okay, first of all, let's draw this in algebra. Let's draw the, okay, I'll turn this off. So I'm going to write down y equal to y equal to ex raised to power x minus 1 over x. So exp raised to power x minus 1 and this over x. I get this graph. Did you see this graph? So now if I make x goes to 0, so this graph, if x, say x is 1, x is 2, x is 3, x is -1, -1, 2, -3. If you make x goes to 0, say it is here. When x goes to 0, what is y? Did you see when x equal to 0, y equal to 1? Did you see this? When x goes to 0, y goes to 1. Okay, so that's justified. This limit is 1 because it is the same as ex raised to the same thing. They just change the number, the letter, I mean. Okay. So any questions? All right. So we did that part. Now let's do an example. Find the derivative of A. This one, we need to use production rule. And remember what is the production rule? D dx, if you have fx, gx, this is production rule. So it is equal to fx times d gx plus gx d fx. This is product rule. Apply this rule to x squared times ex. The first step, you get this one here. Fx is x squared, gx is e raised to power x. Okay? And the derivative of ex is just ex. Derivative of x squared is 2x. So this is the final result. Any questions? So this is A. Part B, take derivative of gx. So copy down the and raise to power. So find the derivative of g. Find the derivative of g. And this one, first of all, remember x raised to power n derivative equal to n x raised to power n minus 1. First, apply to this rule. So n is 3 over 2. X is et plus 2 is x. Raised to power n minus 1 means, maybe I will do it on the side here. So in this situation, n equal to 3 over 1, n minus 1 equal to 3 over 2 minus 1 equal to 1 over 2. That's how you got this 1 over 2 here. N times x raised to power n minus 1. Okay. And then you have to use the chain rule. You have to take derivative of this one, because you consider this one as the big X here. Okay, so keep on going. Okay, this part you copy down. The derivative of et is et, and this is the final result. Any questions? All right. So next one, apply chain rule to exponential functions. So if you have e raised to power fx, what is the derivative of this one? So we know the derivative of ex is ex, but here it is not e raised to power x. It is e raised to power fx. So we have to use the chain rule. Okay, so the result is e raised to power fx, then take derivative of fx. Let's take a look at example. So e raised to power 2x. Okay. The result is e raised to power 2x because ex derivative equal to ex. And then take derivative of 2x. Derivative of 2x is 2. Okay, so this is A. So B, y prime means derivative of y equal to e negative 3x times derivative of e negative 3x. No, derivative of, or maybe I will write down, you correct the mistake. I make mistake on purpose, okay? Derivative of e negative 3x. What is wrong with this one here? Something wrong here. Where is the mistake? Where is the mistake? Anyone found the mistake? What is the mistake?
It's supposed to be ddx of minus 3x.
Thank you, Andre. So supposed to be just derivative of negative 3x. So negative 3x is fx here, the function here. Just f prime x. Okay. Okay. Keep on going. So equal to e negative 3x. Negative 3x is negative 3. So the final answer, negative 3 e raised to power negative 3x. So that is B. Okay. Now let's do C. GT. So what is the derivative? This is C. GT derivative. Okay. So the derivative of E, which is EX, E. Then take derivative. Then I will make mistake. You correct my mistake, okay? I said d dx, then 2t squared plus t. Where is the mistake here?
Should it just be 2t? Would it just be 2t?
Ying, thank you. Great observation. Sorry for the dog. There are 2 dogs. Yes. So d dt. Okay. Not dx. So equal to e 2t squared plus t. Then derivative of this one is easy. Polynomial derivative, okay? So 4t plus 1. So final answer. Usually we put this in the front, usually. So this is the final answer. Okay. Any questions? So that concludes our lecture today. So in summary, we did 4 sessions. Session 1 to session 4 of chapter 5. Topics include exponential function, logarithm function, derivative of exponential function, derivative of logarithm function, as well as compound interest. Okay. Any questions? One student want to see my dog. That's fine. See the dog. Can you see it? Leia. This is Leia, 4 months old. The other one is Mary. Mary is 1 year and 1 month. Mary.
You're so cute.
Okay. Yeah. Thank you. That concludes our lecture today. Thank you so much. Next week will be in-person lecture in D house. In-person lecture. Okay.
Can I ask a question that's not?
Oh yeah, we have questions.
this?
Yeah, we have time for questions. If you don't have questions, feel free to go. If you have questions, I am here.
Thank you. Have a good night.
Thank you so much. Okay. Sorry for the dog barking. Actually, she likes to talk to people.
It is based on the assignment. Is that okay? Or no?
Could I turn my
Thank you and good night.
Any questions? Type your question in chat area or directly speak up.
I'm so sorry. I'm just getting it out. Is it okay if it's related to the assignment?
The assignment?
Yeah.
What is it about? Sorry, what is your question?
Mark, could I change my class to an online class?
Oh, sorry, it is too late to change the class.
Okay. Thank you.
I know the online class, they will have online test too. This may be some concern for some students. If the question is on the assignment. For Leia, yeah, you can have question about assignment.
Okay, awesome. I'm gonna pull it up.
Okay, great. Maybe I will just stop recording because this is lecture ends. Okay, give me 1 second. I will stop recording.